John, just making sure you're there. Can you hear me? John, can you hear me? Just making sure that we're back on. I think you might be muted if you can hear me. To the control room, the audio, can you confirm if my audio is going out? I can see you, John, but I think, oh, audio okay, but I can't hear John though. John, can you hear me? Let me see. Oh.
Let me try that. Can you hear me, Abel?
Yeah, you came in for a second there. Can you hear me now?
I can hear you. Can you hear me?
Yes, I can. Okay, excellent.
Okay, let's go with this. Okay.
Yeah, so digital transformation, John.
Yeah, right.
You know, right. So this is a great example for the audience, you know, of the type of challenges that we will be speaking about, right? You have here different countries, different cultures, different setups, different technologies, right? Because we're used to using Zoom, and you know, I think the second most common probably is Microsoft Teams, and now StreamYard, you know, is yet a new service, right? And so, in many ways, you know, we're we're illustrating some of the issues that we will be going into. But John, maybe we should jump into the presentation, and this is the slide that we'll hold for the first 30 minutes.
I was just going to add one, Abel, I was just going to add one comment that our problems were security, that our cameras and audio, you know, they were being locked down by Mac security, and so we had to release them to StreamYard so that StreamYard was allowed to access. And that's pretty common today, that the big blocker, you know, as soon as you move to the cloud, it is security, that it's pretty horrendous levels of security that you have to navigate. So this was a good example.
No, that's a great point. And in some ways standards, because although we're using a browser and you would think that the browser is universal, it is not, right? Like I have 4 different browsers on my machine, and I was iterating through them. And as you say, it was actually Apple who has increasingly added security, you know, around social networks, around devices, around browsers, and you know, can this browser use audio or not? And I don't use my main browser for security purposes as well. So we're hitting, you know, up against standards, against security, against, you know, learning curve and standards as well, because, you know, StreamYard is not yet, you know, a mainstream standard. But John, do you want to jump into the topic?
Well, I think what we'd like to do first is just, you know, ask the question, where are we today with, you know, software and digital transformation? And here we've got, you know, 5 of the topics that we think are the technical basis, if you like, for digital transformation. And so we should probably just step through what's missing here is the web, which really started all of these issues about cross-machine computing. I mean, one of the things that we're leveraging today is we're going across machines. We're talking to StreamYard, and then StreamYard is broadcasting out to all the participants. It's a fairly complicated setup, and the complexity of most of the apps today are in that league. So Abel, maybe we should go back to, you know, the internet and the World Wide Web and what that really brought to us.
Sure. And just before I jump in, I'll just give you a little bit of an overview of where we're heading. We'll do roughly 30 minutes of this front part where we'll talk about digital transformation and broad terms. Then we'll give you an exercise. We firmly believe in action and letting you touch things. We'll give you an exercise, and then after that, we'll come back and we'll do another 30 minutes. The other comment to make as well is please feel free to ask us questions. We're quite comfortable at taking questions on the fly. So it adds to the interactivity. It can be challenging to engage with you, right, remotely, but please, in fact, why don't you say hello now, in the chat there to just get a sense of where you are. I know what country you're mostly coming from, but it'll be different cities for sure. So I'd love to see you, say hello and see your entries there in the comments. And don't be shy because I don't see any yet. So I just want to make sure that that we do have an audience out there and we're not just broadcasting to the studio.
Yeah, that's interesting, actually. Yeah, the feedback is good. If we can get some idea of we'll ask you about your interests as well later. But
yeah,
we've been teaching like this for a while, and it's certainly brought a revolution to teaching and education. So it would be good if we can see some comments from you. I'm not sure if they're coming in.
Control room, if you can confirm that the chat is active and that the participants can in fact type into the chat. And so once again,
it's listed as comments, right? It's under comments or not?
Yeah, I've been looking under comments, but I don't see it.
No, I don't see any either.
So again, be brave. Be the first one to say hello. We'd love to hear from you. Just to know that we're speaking to a live audience.
Actually, we should give some introduction to that sounds able and just say.
Yeah. Go ahead, John. That's a great point. There it is. Hey, somebody's there. So say hello. I'll say it in Spanish in case it's not getting through. Nos gustaría, buenos días, buenas tardes, buenas noches, dependiendo de donde estén. Nos gustaría mucho escuchar sus comentarios y saber que estamos hablando directamente con el público. Así es que si pueden compartir un hola y decir en qué ciudad están, nos gustaría mucho escuchar de ustedes. Yeah, John, I'll go ahead and start it. We are in the city of Boston, to the north of New York, because most people tend to know where New York is, about 3 hours drive north, in a university called MIT. It's a university renowned for its technology, and we both are passionate about technology. We've been working on this on the research side and applied side for well over 10 years. We've worked with some of the biggest companies around, the big consultancies like Accenture, automobile companies like Ford, software companies like Microsoft, enterprise companies like SAP, and the list goes on and on. The reason I mention all of that is just simply to emphasize that we are pretty applied and we work with industry quite regularly. So, we work both in the classroom and the research side and on the applied side. So with that, John?
Yeah, as Abel's saying, both of us code almost every day. We find that seeing other people's code actually allows us to learn pretty quickly how their products are working. That if you can look at code, it just helps a lot. What we're seeing is that the rate of change of technology is so rapid these days that new technologies are entering the market and getting adopted in months rather than years. That you see a company like TikTok that's kind of come out of nowhere to challenge some of the biggest companies in social media. And we're seeing that all the time. And obviously, everyone is wrestling with these new technologies. In education, obviously, video like this has altered education totally, that the business model for education now has changed radically. So some of the things that Abel and I wrestle with is certainly computing at scale. The nature of computing itself has radically changed in the last 15 years since the internet, and certainly since the World Wide Web came along 20 years ago. Everything now is distributed, and we'll talk about that because it introduces a lot of complexity. As we saw, here we're struggling to have machines talk to machines. That here we had to allow StreamYard to access our resources, if you like, our video stream and our audio stream. And that's typical of computing these days, that we really don't care much about the computing language that applications are written in. It makes a difference sometimes, and we'll talk a little bit about that. But in general, today applications are talking via messages. And this is what we are seeing here, that we're actually streaming data at you, and it's a video stream. That's fairly big data. In the next hour or so, we'll be streaming many gigabytes of data across the web, and we're doing it easily. Abel, I think that's enough introduction to us and what we care about. As Abel was saying, we both teach. We've taught with consulting companies like Accenture, Microsoft, SAP. We're very familiar with their products and the challenges of adopting them. Abel, maybe we should get back to our first goal and talk about this digital transformation that everyone's going through.
Yeah, absolutely. And I'll start here at the beginning of computing, and I'll bring it quickly to something that you'll recognize more easily. And I think in many ways, the challenge of getting work done has to do with bringing information together. You can see here that we're engaged in precisely that, right? We're trying to communicate to you some information that we hold. You can imagine that prior to this engagement, the organizations that made this possible, the coordination of South America, North America, and so on, had a number of exchanges. And so in many ways, since the early days of computing, we've recognized first, right, that this is needed, and we've started to do that work, right? In the 1970s, a lot of this had to do with being able to lay the foundations, TCP/IP, to be able to communicate. In the 1980s, by the 1980s, a few thousand computers had been connected, which I know sounds like nothing. Any office building has that today, but at the time it was a big deal. You could connect 3,000 organizations around the world, and it was a great achievement. However, when it came to being able to directly connect to another document, it was pretty difficult to do. You needed to do what is often referred to as out of band. You needed to call the engineering team. You needed to coordinate. You needed to have meetings. Again, it was too expensive to do, right? Not that it wasn't possible. It was perfectly possible, but it was difficult to do. And so a researcher that becomes worldwide famous and then goes into obscurity, again, because nobody knows who he is today, even MIT students, even though he has an office, here on campus as well, proposed a standard to be able to do this. And it was beautiful in its simplicity, compact, half a page long, and transforms the world when it comes to communications. It makes it possible to be able to reach out and connect to a document. And by the end of that decade, now the 1990s, you have hundreds of millions of documents that are connected, and you have, the beginnings of a transformation in business. And so we're sort of off on our race, right? So John, I wonder if you want to pick it up there from the Web 1.0 point forward.
Yeah, so Sir Tim Berners-Lee that I was talking about is quite a revolutionary hero in many ways. Even though today the students don't recognize what he's done. But I think one of the other things he did was he made machines easily addressable, that we can talk to a machine now by its URL, that we type HTTP, www.mit.edu, and that addresses a machine. Now, that makes it easy for us to, for example, to address any device across the world. We can talk to a camera in Beijing just as easily as we're talking to StreamYard here. And we don't even know, I don't even know where StreamYard is running. It's running on some servers, it's probably running on AWS or one of the big clouds. But that ability to talk to a device across the world and actually send commands to it is huge. That we can now control a drone remotely. We can, control robots remotely. And so URLs now have given us this ability, and especially URLs that are kind of entered through, say, your smartphone. You go to your browser, enter a URL, it takes you to a device somewhere across the world, and you can issue commands, and also you can ask for data to be sent back to you. So there could be a drone flying over, say, Afghanistan today, and we could be communicating with it fairly easily. So these technologies that were just in the provenance of a few companies now, have been democratized, that everyone can have access to them. And so to some extent, we've got this challenge of, okay, we can get data from thousands of devices. What do we do with that data? And, these pillars that we're laying out here are the building blocks of what a modern company needs to master to be able to leverage data and, make data-driven decisions. Abel.
Yeah, absolutely. One of the things that was going through my mind as you were describing this is precisely StreamYard, right? Because there's been an evolution, and maybe I should say a little bit about that, because I think it's not obvious what the change has been. If you think about the 1990s, and I know a lot of leadership, given that we're mature, we have gray hair, grew up computationally, I should say, in the 1990s. And the landscape was very different. The dominant mechanism or model for delivering software was proprietary software. That means software from vendors like Microsoft, databases from places like Oracle, and purchasing the software, being able to install it in your organizations was something that was not simple. The installations lasted years, and over 70% of them never completed. And so you can imagine that given the great amount of expense, the challenge and the risk that you ran, being able to successfully do these installations, the decisions for making purchases when it came to IT was done at the top of the organization, right? And the world was drastically different. I'm sure you remember, driving to the store and looking through the shelves and being able to pick up, one of these boxes, and you came home and you took out your CD and you put it in and you loaded your OS. Remember Windows 95 and all of that. But the world has changed, right? Around 2001, Salesforce introduces cloud services, a new way to acquire this software, without having to do installations. Now, in that year, 5% of Americans had broadband. So you can imagine that the banks had, I think, 1% of their customers were online. 10 years later, by 2010, over 60% of Americans had broadband. And the world had woken up to this possibility. You had companies like Amazon Web Services that had started to deliver computational blocks that you could use in a very different way. And so as opposed to being centralizing and being slow and having these long decision cycles at high risk, you can now consume these small pieces without having to build all the infrastructure. And again, related to today, I remember at the end of the 1990s, running video conferencing software, we were collaborating with Japan. And I could tell you still now that if we had over 70 milliseconds delay, the connection was too flaky for us to be able to maintain those discussions. 10 years later, we were still working on proprietary. And when you use Zoom, you're still using a native client running natively on your machine. What we're using right now is a pure web protocol, right? Something that you do not need to do an installation. And so you can see there the agility and acceleration and the change in model, right? Today, we're picking components off the shelf and being able to integrate these with much more ease, much more speed, and at a lower cost. We don't need to do those capital expenditures. And it's a very different world, right? And some of it there is captured by the cloud model. And the cloud model is so much more than cycles. We tend to think of it, okay, it's servers and places to store things in. John, I wonder if you want to say more about what the cloud
Well,
is.
yeah, I'd like to, complete the World Wide Web story that,
Sure.
by the end of the 90s, we had the browser. And as Abel is pointing out here, the browser is an amazing integration platform. What you're watching now is you've got a web page that's got injected into it, 3 video streams, plus picking up the slides. So it's bringing together 3 or 4 things. In general, if you look at what your browser is doing, my favorite is to hit, say, the Wall Street Journal, and you're actually going out to about 100 different servers. So the browser's become basically our window into the world, that the browser runs on every device or on most devices. It may not be the same browser, but there is a standard there that makes it much easier for people to interface with. So today, every company has a website. Interestingly enough, not many test your website. If you go to Chrome, you can bring up, it's a whole development environment that sits in the Chrome browser. But one of the items in that browser is something called Lighthouse. And if you point it at your website of your company, it'll rate your website, how performant it is, and a lot of other issues that you'd like to know about your own website. So try it. Go to Chrome or ask one of your technical people to go and use Lighthouse and point it at your own website and see how performant it is. I tested several of the websites in MIT, and they got scores of like 36 out of 100, which is pretty poor. You should be up in the 90s out of 100 to be performant. And companies like Amazon and Google have mastered this. They know that if you're kept waiting, that you won't actually stay on that website. And you see today the quality of websites such as Robinhood that are so good that they captured, literally billions of our investment because they figured out how to interface with their customers and give their customers a really amazing interface. So that's the story of the browser. Your company is probably marketing products through the browser today. Certainly, you're getting information from other people through the browser. So that's one of the main building blocks that you have to master. And typically the language of, we call it web computing, is JavaScript. The browsers understand JavaScript, and that's the natural language for getting things into the browser. So that's one area your company needs to master. And I'm always amazed companies like British Airways have such poor websites. They're selling tickets over the web, and yet they certainly haven't mastered performant websites. So that's the story of the IoT, is that now we've got all these devices that can talk to each other. We've got a lot of data, and along comes the cloud with machines that can help us analyze that data. Abel, maybe you want to talk about the cloud era and how it started with Google having spare machines.
Sure, I'll try to bring a few different pieces together here. A lot of it is, much like the diagram here about how do you think of these things in a way that you can put your arms around it. One thing that we're working on is, these generations of the web, Web 1.0, connection of documents, 2.0, connections of programs and data, 3.0 could be IoT, the physical reach into the physical world. And the fourth one could be blockchain, and we'll say more about that later. Now, when it comes to the cloud, the IoT part of the world is sensing. You have an increasing amount of instrumentation in the world. You have it in sports, you have it in mining, you have it in transportation. Everywhere you look, even within your home, if you start to look around at your devices, I'm sure you have now devices that you're connecting directly to the router in your home. Now, all of this is generating a tremendous amount of data, right? And in the past, we were challenged by our ability to be able to store that data. Now, when it comes to the cloud has practically an infinite amount of capacity, right, for you to be able to make that storage. And the great thing about the cloud, as I mentioned earlier, is that it is not just storage and computation. This is how it started. And often this is called, platform as a service or infrastructure as a service. Platform would be one level above that. And it turns out to be tremendously convenient because you spend a great deal of effort as organizations. And I know in Latin America, and not just in Latin America, in other countries as well, it's quite common to run your own data centers. And as John and I like to say, friends don't let friends run data centers. And what we mean by this is that there's a tremendous amount of complexity in being able to run a cloud, one. Two, expertise that is needed to be able to run it efficiently. That means that you're not losing money compared to just outsourcing it to somebody else. Three, adding the richness when it comes to the programming layer and services that you provide. There's no possible way, unless this is your business, that you will be able to do this better than Amazon, better than Microsoft, better than Google, right? And so the studies, economic studies, are well, proven by this point about how much better it is to run it with them. Even if you were just simply using that very first layer of infrastructure, you would still be doing better, right? And as you go up the tiers, there's a great deal of more services. There's platform, forget about what's underneath. I don't want to patch these machines. I don't want to figure all these things out. You can work at that level. You can go higher to manage services. You can go higher to serverless. And so depending on what your needs are, you can go cloud light or cloud heavy. But ultimately, there's a tremendous amount of resources. Even if you're thinking about the services themselves without using anything else of the traditional cloud components, like, for example, servers and the type of things that in the past, form what you thought about as cloud. Even if you're just using, say, artificial intelligence algorithms simply as a resource, you have all your software in-house and you want to go out and connect to this, you would still be much better served than trying to develop that in-house. It takes a long time. It requires very deep expertise. And you'd be competing against the artificial intelligence engineers of Google and Microsoft. If you think you can do that better, then your valuation should be much higher, right? Because you basically have that kind of talent. So there's a tremendous amount there. And one of the things I like to say is that if there was a company in the world today that used all of what Amazon Web Services offers to the world, it would be the most advanced company in the world, because even Amazon itself can't use everything it has, because even they can't keep track of how many things they have. So, John, I'll pass it back there.
Yeah, my example is, it brought it home to me when I discovered that I could run a machine in London, which allowed me to appear to the world as if I'm sitting in the UK. And so I could access the rugby games that were being broadcast on BBC and ITV from, in London. And that machine cost me $5 a month. So, $60 a year. And I've got a machine sitting in London that's up all the time. And all I have to do is switch on my virtual private network, my VPN, and I'm talking to the world through London. So it brought home how cheap these machines are, and the fact that you don't have to patch them. You don't have to provision them with expensive software. Now you can do, but as Abel is saying, Amazon has been particularly good at leveraging open source software. And that's something else that came along. Basically, open source now has literally millions of libraries. If you're a software developer, you're using GitHub. GitHub has over 1 million libraries available, or projects, repos available that you can search through. And what we tell our students now is the first thing to do is not, how do I write this code? It's first search to see if somebody else has already written it, because the chances are you'll be able to find something pretty close to what you want. There's a famous story of the government in Australia, in one of the towns, wanted to monitor all the cars coming in and out of the town and read the number plates. And companies bid on it, and I think the cheapest bid they got was something like 20 million. And they gave that money to the company. Later, one person, a hacker, decided he'd take on that kind of task of writing this, and he wrote in 1 week the equivalent of this $20 million project. So one of the things that you have to do today, if you're a manager, is you basically have to make decisions about, what do I buy? What's freely available? Now, both Abel and I, we test on freely available software, and then if we were a company, we'd switch then to maybe software that was supported by, say, AWS. So you can find a lot of the building blocks are free, and you can test them out, because today most of the complexity comes not in a single application, but multiple applications talking to each other. And so you can test out the setup. You can get free database, you can get free streaming database, you can get web servers that you can spin up basically in 5 or 10 minutes. And so you can rapidly test out these building blocks. So open source, you may want to start building your company on that, but then switch to standardized building blocks such as AWS provides. So they've been, they've been castigated for taking open source and turning it into products that you then have to pay for. And that happens to be their business model. But now I think they're trying now to give something back. But that's the way they operate. And as Abel is saying, AWS have literally thousands of products available. You won't be able to access them all. But coming back now to, we have all this data, we have ability in the cloud to spin up machines and provision them. We should mention Docker containers. Maybe you can pick that up, Abel. But sure. Then we need to have something that can interpret all this data. And along comes machine learning. In 2012, Geoffrey Hinton figures out how to analyze images so that the machine can understand what's in the image. So we're stepping into the AI now and machine learning to help us interpret the data, this tsunami of data that comes from IoT devices and can be stored in the cloud or can be directed, can be streamed through the cloud. Abel.
Sure. I think before we go forward, I'd like to attempt to get some comments from you again. Hopefully you feel more comfortable, you know what we're talking about. So if you have any questions or any comments, go ahead and enter them into the chat. We'd love to hear from you again. We'd love to get some questions. I think it's more fun if you participate. So I saw the hello earlier. Thank you for the hello. But
we have one viewer.
Yeah, that's right. That's right. So I'd love to hear from someone, even if it's let me try this question. I tried it in Chile. Let's say if you can beat Chile, right? I tried it in Chile, and the question was, what are you most concerned about when it comes to technology? I'm sure some of you have concerns when it comes to technology. I'd love to hear one, concern. How many are in the chat? I'd love to know from the control room. You must know how many are connected. Let's see, control room. Hopefully I'll get a comment from them. Anybody out there? Any questions? I feel like the caller, I mean the actors in the movie, when they were picking up the phone, and they were saying, hello callers, or on the radio, I should say. Do we have any calls, right?
Leo, you're famous.
Oh, you have 3. Leo, thank you very much for your comment. That is great. There's just 3 people. Let's see. We're
Okay,
waiting for comments.
we can. Why don't we have a discussion?
Yeah, that's right.
Let's bring up everyone.
Yeah. Yeah, I think that makes it more fun.
We'll take questions.
Yeah. Control room, can they open up their mics and just speak directly back to us if there are 3 people? That makes it very easy. So there's a question. I think this is from the control room, and she's asking, what do we think the situation is like in Latin America? I think there's a misconception about,
It's the
U.S. versus
IoT,
Latin America.
IoT situation.
Is that what it is, Olga? Can you confirm if it is IoT that you were referring to?
Yes, it's about how do you think is the situation of IoT in Latin America and for the future?
So let me answer that. Oh, that's great that you're putting the questions over the stream. I think in many ways the challenge with IoT is not so much the hardware
IoT.
or the infrastructure that you're building. It's more building a data organization, because I tend to think of it as the source of the data, right? So it is your sensing mechanisms out in the field. And so I'll give you an example from sports, right? And that in the world of tennis, you can have up to 11 people judging the lines, right? Like somebody hits the ball, like some people can serve at over 100 miles an hour, right? And that some can do it over 130, right? And being able to judge where the ball lands, they get it wrong a lot, right? And on the course of play, there are over 11 line judges on the Grand Slam tournaments. And yet, over the past 2 years, there's been a transition to full automation, meaning that the latest tournaments, at least in the early rounds, are running without any line judges at all. And all of this is being done by technology. Now that you have that on the ground, you can start to collect all of that data. Once you start to collect that data, you can start to do comparisons between different players, different countries. All sorts of things appear to be possible. Now, in order to be able to start to do those analysis, you have to go through the effort of building an organization that can make decisions based on data. And the second part of our talk is going to be precisely about that. But that would be the first part of my question. And when it comes to the challenge specifically of Latin America, I think there's been a tremendous amount of investment in the US to be able to build these data practices, I would call them. However, the technologies and the expertise are globally accessible anywhere. I think the only difference I'd say that in Latin America, perhaps they're earlier, say a couple of years, perhaps in general, to starting that effort. John?
Yeah, I mean, I would say that supply chains are probably fairly standardized across the world. That's one area where, the standards, EPC Global has set a number of standards so products can be tracked. So my sense is that's one area that most companies have mastered worldwide. It's slightly different if you don't have good broadband, but today most countries do. We were involved with Philip Morris in tracking cigarettes, and they were tracking them right down to the stores, the tiny stores in Vietnam or wherever, and they were using FTP back then to monitor where their goods were. But in general, supply chains have been very good. But as Abel is saying, leveraging that data actually in anywhere near to real time is really challenging. What we're seeing is that the companies that have mastered handling data, well, not only handling data, the first thing is to get data. The problem the banks have is that they don't have as much data about their customers as other companies like Google and Amazon and Facebook. And so they're left almost not flying blind, but certainly not having great vision. So the first thing is getting the data so that you can understand what your customers want. You can run tests to understand better which products they prefer. And you can also get feedback from the customers. I mean, the prime example is Netflix that monitors exactly what you're watching. So, you know, it serves you up a selection of products. You choose the product. They know which product you like. They can then serve up and they can refine, you know, how many people like adventure movies, how many people like cooking shows. And so they have great data about their customers, and then it allows them to compete at less risk than Hollywood. And Hollywood is basically sidelined. They know how many theater seats, cinema seats, you know, are being sold at the weekend, but they really are not in touch with the customer in the way that Netflix is. You know, Netflix is in touch with hundreds of millions of their customers every day. If you rewind the movie or wind it forward, you know, the 10 seconds, you can move it, you can skip a scene. They know what scenes you're skipping. They can analyze which actors and actresses you like or don't like. So basically the game that the game that data allows you to play is that you can make better decisions with less risk. So that's the problem for most companies. And, you know, with Uber and companies that have come with a totally different business model, it's difficult if you're a taxi company to get the mindset that there is a totally different business model out there. You know, you think your game is to run taxis efficiently, but somebody comes along with a totally different business model. We're sitting in academia wondering, it seems there's a different business model to building universities or building high schools, that obviously online is cheaper. Your reach is hundreds of thousands rather than tens. And so there's different business models that are becoming available. So what we want to talk about and show you today are these building blocks for this digital transformation. And digital transformation is also about different business models that these technologies allow. Abel.
Yeah, I think the one thing that I'd add there, and I think it's Olga, right? Yeah, it is Olga, is that there's also an infrastructure component. And for this, you know, I'm referring to the investments that some companies have made in Europe and some in the US to be able to provide a network layer. And when I mean network here, I'm referring to the same thing that the telecoms have done, right? To be able to connect cheaply to that infrastructure, right? Because if you have, say, great devices on your vehicles or in your equipment, but you have no practical way of picking it up, then you're back to, you know, being able to do it, you know, at the end of the day, or being able to do it once a month, or, you know, however, whatever cycle, you know, the business you're in allows you. But once those infrastructure investments are made, and I'm not familiar with the ones that have been made in South America, but here in the US, you know, the telecoms have gotten into the coverage in cities because they already have all of the towers, right? And so you can imagine that if they're not doing it already, it's a service that could easily be provided, right? And they, you know, it's the technology already exists, you know, small devices that you can put in, and then you connect to the local towers, right, that are spread around all the cities. When you get out to the open field, you know, the spaces in between cities, there's where it gets, you know, more tricky. But there's a tremendous amount being done, you know, with satellite. And if you've followed the press, you will have seen some of the networks that are being built. You know, I think it's, of course, Starlink. I think it is the one from Tesla. You know, they're building a network. Facebook is doing similar things. And once this gets in place, then you will have global coverage everywhere, right, through these connectivity networks. And so I think even if South America doesn't have it yet, this is coming soon. And the other thing I would say is that the challenge is, how do you start making decisions, just like John was saying, based on this information? And there's a whole infrastructure story as to how to do that. And I mentioned earlier that South America, or Latin America, not just South America, is starting to make these investments, but they're early in the curve, right? And that I think there's still a great deal of confusion in the US as to the role of, say, the data scientist, the data engineer, the AI engineer, which is different than the data scientist, and some of the other roles, data architect, and so on, and what the components of this infrastructure need to be for organizations. A lot of what I would warn against is to outsource this to consultants, because most of the challenge that exists in the world today is about moving fast and being flexible. And when it comes to telling someone else what you want done, it takes you a long time to decide, and when you go build requirements and, form committees and, put that out to RFPs and wait for that to be done, it's not unusual to have 18 months. And some people say, well, we'll be lucky to get the, the approval in 18 months, right? Now, if you have small teams, and this is something that we have seen consistently be a great way to achieve this, and I'm talking here between 5 and 8 people, this is a much better approach, even if you don't have the expertise in-house. But you can find people that are highly motivated, want to learn, want to grow, to give them small budgets and set them off at doing one of these things. And that turns out to be a pretty good approach. In fact, let's give you $1 billion and watch the digital transformation we've seen has horrible results. So, John, I think there's a question from Leo about small manufacturing companies. I don't know if you want to take that one.
Yeah, I mean, I'm wondering. I think we probably won't do the making toast. Okay.
No, I think we'll wrap it up at the hour here, because we're pretty much at the end.
Yeah. I think so too. What I'd say about manufacturing is that there's a great example of making a bread machine. It turns out that I should also say there's a great book by Eric Rice called Lean Startup. And his pitch is that the world out there has changed quite rapidly. These technologies are available now that weren't available 10 years ago. And so you really need to be able to test out your assumptions about, how your product is being used or is going to be used by customers, what they feel about your product. And so you need to build in an ability to learn from your product. And in the case of the bread maker, they built in they monitored the bread maker so that they could tell when components were about to fail. So that's one thing that you can do, is monitor your product. But then they also got feedback from the user, so they knew if the bread was good or not. Was it baked properly? What did people prefer? And they learned a lot about baking bread, basically. So they got up to scale, and now it's very difficult for any other company to catch them, because they're learning faster about making bread than anyone else. So view your product not just as, oh, we need to sell this. View it as something you're going to learn from, and learn about your customers, learn about what your next product should be like. Because if you can learn faster than your competition, you're home and dry. So don't just think of it as the product itself, but as, okay, now we can put devices into that, and they're cheap. Wi-Fi is cheap. Wi-Fi chip is about $1. Whatever, you can build in communications technology into your product. And so, today, airplane engines are all monitored. Almost, we've got in our house. I've got, I don't know how many Alexa machines, Alexa Dots and Alexa. I think I've got 13 or 15 devices that are talking back to the manufacturer. Actually, I had a notice today, Abel, that my Roku is out of date and that Amazon is not going to support it any longer on Amazon Prime.
Wow.
So they knew exactly which Roku I have, because they can ping it. Pretty interesting, I thought.
Yeah.
Anyway, I mean, I think that's our pitch, is that these technologies need to be leveraged, and it'll vary depending on your industry how you leverage them. But certainly, having minimum viable product, and certainly starting small, touch the cloud, get going, understand what's available, and then figure out how to leverage the data that you can collect. And data itself is valuable. Once you've analyzed it and got insight from it, it's even more valuable. Abel, any?
Yeah, I think we can call it there, John. One thing I would recommend is do some reading. There's some great books. Project Phoenix is one of the ones that sort of introduces you to this world. There's a few others that follow on from there, but it's a great opportunity. I mean, I think for any of those that are watching this on playback, there's a transformation going on, and John and I like to say, well, there's going to be an extinction that takes place, and I think right now you have the advantage in some domains, right? That the big digital giants haven't moved in, but they're moving in all over the world. They're moving in India, trying to integrate the informal economy. It's not going to be long before they come to Latin America and try to do the same. And they have the capabilities to transform landscapes. And so there's some great opportunities, just like we've been saying as well. The infrastructure is available. You can participate this, but you have to change your mindset more than anything else. John, I wonder if you want to say anything else.
No. I mean, I think learning is important, but the world is changing rapidly. And so, look upon this as an opportunity to learn about these technologies. You can get to grips with them pretty easily. You can start in the cloud very cheaply. If you want to learn about machine learning, go to Colab. It's Google's kind of free resource, and you'll have a machine dedicated to your Colab notebook, and you can learn very fast about some of these areas. So this is what Abel and I are basically spending our time on now, is developing content in these areas so that you can understand very rapidly what you need to master, and also how you need to go about mastering it. And it's not converting the whole company in one go. We'd recommend start small, but move fast. Think in terms of months, and in 1 year you should have mastered a lot of these technologies. I think that's about. I think we've given our message, Abel.
Yeah. So thank you all. Thank you, Leo. Thank you, Olga, and take care.
Okay.
Bye.
Yeah. Cheers, Leo. Thanks for helping. Cheers, guys.